Hello learners, welcome to the next lecture of week 4 of our course on Introduction to Electric Vehicle and Hybrid Electric Vehicle. Till now we have reviewed the different vehicle architecture and their different attributes. This lecture aims to provide a comprehensive comparison among different vehicles that we have discussed till now, such as internal combustion engine vehicle, electric vehicle, hybrid electric vehicle, plug-in hybrid electric vehicle and fuel cell vehicle technologies, focusing on their critical metrics including emission, fuel, efficiency, advantages and disadvantages. By systematically analyzing these factors, we can better understand the relative advantages and challenges associated with these vehicle technologies. In addition to comparing these technologies, the lecture will also examine the essential role of power management and control strategies for electric vehicle and hybrid electric vehicle. Effective power management is crucial for optimizing vehicle performance, extending battery life and ensuring efficient energy utilization. We will explore the two primary categories of the control techniques, which is rule based system relies on predefined operational rules and conditions, and optimization based system which employ advanced algorithm to dynamically optimize the entire vehicle system based on real time data and predictive modeling. So, the objective of this lecture, as mentioned previously, is to understand and differentiate among different vehicles, their key differences in terms of the performance, in terms of the fuel efficiency, in terms of the advantages, disadvantages and the kind of issues and the challenges that they are facing. Another objective is to learn about the power management in this vehicle, specifically in electric vehicle and hybrid electric vehicle, and to discuss recent development in power management techniques and technologies. So, the electric vehicle including hybrid electric vehicle, plug-in hybrid electric vehicle and fuel cell vehicle each bring unique capabilities and face specific limitations when evaluated across parameters such as emissions, performance, fuel efficiency, driving range, size, weight, cost, safety, comfort and all. These diverse characteristics determine their suitability for different applications and market segment. So, if we look into internal combustion engine vehicle, then in that the propulsion system is the IC engine based drive, energy storage is the fuel tank and the energy source infrastructure are the petroleum product or gasoline product with refueling stations. If you look into their advantages, then it is a mature technology, fully commercialized, it has better performance, simple in operation and quite reliable and durable. However, the disadvantages are it is less efficient, poor fuel economy, it has severe harmful tailpipe emissions and quite bulky in nature. In addition to these advantages and disadvantages, some of the important issues that need to be resolved in IC engine based vehicles are fuel economy, the tailpipe emissions, highly dependency on the petroleum product. These are the few advantages, disadvantages and issues associated with the internal combustion engine. In a similar line, if you talk about the electric vehicle, then the propulsion system is the electric propulsion system based drive. If you talk about energy source and storage system, then it is a battery, ultra capacitor or flywheel or combination of these, making it an hybrid energy system for electric vehicle. Energy source and infrastructure is the electrical energy and charging facilities, which is quite limited as of now. If we talk about the advantages of the electric vehicle, then it is highly energy efficient, it has very less noise, quieter operation with zero emission, the commercialization is taking good space and it is rapidly commercializing. It has a smooth operation and completely independent from petroleum products. If you talk about the disadvantages, then certainly it has a limited driving range which may vary from vehicle to vehicle, high battery charging time and relatively poor dynamic response in comparison to the conventional IC engine vehicle. The moment I say poor dynamic response, it depends on lot of factor. There are certain vehicles that delivers superior dynamic response in comparison to the internal combustion engines. So, it entirely depends upon the design and sizing of the vehicle. There are certain issues that electric vehicle facing, which are the weight, volume and size of the battery pack, the vehicle overall performance in all driving conditions and in varying environmental conditions, and the establishment of charging station infrastructure. So, these are certain issues associated with the electric vehicle. Another category of the vehicle that we have discussed is the hybrid electric vehicle. Again, the propulsion system is the EPS and IC engine based drive, a combined both this electric propulsion system and mechanical propulsion system both drives the vehicle together. If you talk about the energy source, since both the propulsion system is combining together, so we have a fuel tank, we have flywheel, we have battery, we have ultra capacitor. And energy source infrastructure, if you talk about, it is an electrical power and petroleum product with refueling station for both, right. So, if we talk about advantages of hybrid electric vehicle, then higher fuel economy, very low emissions, it is well commercialized and easily available in the market, reliable and durable, long electric driving range. The all electric driving range is getting increased day by day. However, the disadvantages of the hybrid electric vehicle is quite costly and bulky, complex system, complexities in control algorithm and large number of component count in comparison to IC engine vehicle or electric vehicle. It faces certain issues such as integration of the component, interoperability of the component, size and weight of the battery pack and IC engine, and the power management of multi input sources and deciding that at what and when IC engine will deliver power and at what condition and at what time the electric propulsion system will deliver power. So, the management between these two is very important. Another important vehicle category is the plug-in hybrid electric vehicle. Again, it has an electric propulsion system and mechanical propulsion system. Energy storage is very much similar to the hybrid electric vehicle and the energy source infrastructure is again very much similar with the hybrid electric vehicle. However, it has an added charging station or charging facility along with it. If you talk about the advantages of the plug-in hybrid electric vehicle, then it has a lower emissions, higher highly fuel efficient vehicle to G and grid to vehicle capability, partially commercialized, gradually capturing the significant market space and extended all electric drive range. If you talk about the disadvantages, then they are the highly complex, impact on the grid. We have to study the moment we connect this car on the grid, then we have to see how it is impacting the grid, higher initial cost, the battery technology which is quite different than the battery that we are using in the electric vehicle and the hybrid electric vehicle, and it requires the sophisticated electronic circuitry or sophisticated electronics control unit. Some of the issue that it faces is the power flow control and management, charging station infrastructure, availability of charging station infrastructure, and the size, weight and volume of the battery pack and IC engine along with the electric motor and power electronics converter. The last category of the vehicle is the fuel cell vehicle. It uses electric propulsion system based drive. The energy storage system available is the fuel cell, battery and ultra capacitor, and energy source infrastructure required is a hydrogen cylinder and hydrogen enriched fuel and hydrogen fueling station. If you look into its advantages, then it has ultra low emission, water as a byproduct, highly efficient vehicle in comparison to IC engine vehicle, but it has a lesser efficiency in comparison to electric vehicle, competent driving range, reliable and durable, independency from petrol and diesel. If we talk about the disadvantages, then it has a high cost, slow transient response, sophisticated electronics control unit is required, and the commercialization is still not that accelerated the way it is accelerated in case of electric vehicle and hybrid electric vehicle. Some of the issues that fuel cell vehicle is facing is the cost of the fuel cell, cycle life and the reliability, infrastructure for hydrogen conditioning, storage, refueling, production, etc. So, these are certain advantages, disadvantages and issues associated with this vehicle. Among these available vehicle options, electric vehicle and hybrid electric vehicle stand out as the most promising alternative to conventional internal combustion engine vehicle. They not only delivering comparable performance across various driving conditions, but also offer significant benefits such as extended electric range, superior fuel economy, higher overall efficiency and ample onboard power and enhanced dynamic response. If we talk about the hybrid electric vehicle, integrating traditional automobile technology with advanced electrical system in hybrid electric vehicle increases control complexities, weight and cost, making them bulkier and costlier than the conventional vehicle. However, hybrid electric vehicles are rapidly gaining market share due to their ability to balance performance, efficiency and lower emissions, making them a promising solution for sustainable transportation. On the other side, the plug-in hybrid electric vehicle, which built on the hybrid concept by incorporating larger batteries that can be recharged from external power source, are currently progressing through commercialization phase. For plug-in hybrid electric vehicle to become commercially viable on a large scale, supportive energy policies and extensive charging infrastructures are crucial, especially in a country like India. The development of robust network of charging station coupled with favorable regulatory framework will be instrumental in supporting the widespread adoption of the plug-in hybrid electric vehicles. Researchers and industry stakeholders are actively exploring key issues such as wheel to wheel efficiency analysis, the impact of charging station on the electric grid and the integration of the vehicle to grid and grid to vehicle technology to optimize energy use and ensure grid stability. In contrast to this vehicular technology, the fuel cell vehicle, which are powered by hydrogen, represent a futuristic approach to electric vehicle technology. Fuel cell vehicle promise zero emission with water vapor being their only byproduct, positioning them as a highly sustainable transportation system. However, the widespread adoption of the fuel cell vehicle is contingent upon overcoming significant hurdle, including the development of efficient sustainable method for hydrogen production and the establishment of a comprehensive hydrogen refueling infrastructure. Although fuel cell vehicles are still in the early stage of commercialization, they are widely regarded as potential key player in the future of electric vehicle technology, offering a pathway to ultra low emission transportation. So, each type of this vehicle technology has its own strength and limitation. While hybrid electric vehicle currently offer a balanced solution with good performance, fuel economy and reduced emission, the plug-in hybrid electric vehicle and electric vehicle provide more significant environmental benefit with further infrastructural development. Fuel cell vehicle represent a promising future technology offering zero emission and long range capability, but they require significant advancement in hydrogen production and infrastructure to become mainstream. The ongoing research and development in this area will shape the future of transportation, driving the shift towards more sustainable and efficient vehicle technology. As the industry continue to innovate and address these challenges, the choice of vehicle technology will increasingly depend on combination of environmental consideration, technological advancement, infrastructural development and consumer preferences. So, that is all about the comparison of the different electric vehicles and their future anticipation and progress. Let's move to the next part of this lecture, which is power management and control strategy in electric vehicle and hybrid electric vehicle. So, the power management refers to the control and optimization of power flow in a system to ensure efficient operation and to meet performance requirement. In the realm of electric and hybrid electric vehicle, power management is crucial aspect that dictates the challenges lies in the control and management of power flow from multiple energy sources such as battery, fuel cell, internal combustion engine, etc. to power electronics converter and subsequently from these converter to various vehicle loads like electric motor, heating, cooling system and other onboard electronics component and auxiliary loads. So, there are certain major objectives of the power management, and they are maximizing vehicle efficiency by optimizing power flow, minimizing energy loss during conversion, storage and usage, provide adequate power for acceleration and other high power demand scenario, smooth power transition between internal combustion engine and electric motor in case of hybrid electric vehicle, maintain optimal state of charge and depth of discharge cycle to extend battery lifespan and to prevent overcharging and deep discharging of the battery, to ensure safe operation under all conditions including fault management, and to monitor and control temperatures to avoid overheating or to devise better thermal management or cooling mechanism. So, these are some of the objectives associated with the power management strategies. So, let us discuss about the evolution of power management and the control system. In the initial stage of modern electric vehicle and hybrid electric vehicle development, power management system relied heavily on simple on and off control mechanism. This system lacked the sophistication to dynamically adapt to the varying driving conditions, leading to suboptimal performance and reduced efficiency. The primary goal was to switch power source or converters on and off based on predefined set of rules without accounting for real time data. Technological advancement have significantly transformed power management strategies from this rudimentary system to modern adaptive and predictive control system. This advanced control system leverage real time data, machine learning and artificial intelligence to predict vehicle power demand, optimize energy usage and improve overall system efficiency. The transition from reactive to proactive power management allows this system to anticipate power requirement and make informed decision about power flow and its usage. So, let us quickly have a small overview about the key component and concept associated with the power management and control strategies. So, the moment we talk about power management strategies, it always brings three things in a mind. The first thing is the control algorithm, and then the input to the control algorithm, and what are the output to the control algorithm. So, let us have a quick discussion on this. So, a control strategy or a control algorithm in the context of electric vehicle and hybrid electric vehicle is essentially comprising a set of instruction or laws that regulate the overall operation and power flow of the vehicular system. This algorithm acts as a black box performing necessary calculation based on input information to produce desired output or outcome. The control strategies must address vehicle power demand, ensuring the vehicle has adequate power for all driving conditions including acceleration, cruising and hill climbing, monitoring and maintaining the battery SOC within optimal level to prevent overcharging or deep discharging which can degrade battery life. In hybrid electric vehicle, optimizing the use of internal combustion engine and electric motor to minimize fuel consumption while maximizing the performance of the vehicle is another requirement, and managing the power flow to reduce greenhouse gas emission and other pollutant, especially during urban driving conditions. Maximizing the efficiency of the power train component, including the battery, electric motor, IC engine, power electronics converter and other associated component to reduce the energy losses, and to create and creation of the coordination between electrical and mechanical component, which ensures the smooth interaction between the electric motor and IC engine in case of hybrid electric vehicle. So, these are certain factor which should be taken care while defining or designing the control algorithm. Now, the next part is the input data for control algorithm to take care of all the above factors that we have discussed. So, the success of the control strategy depends heavily on the accuracy and reliability of the input data. The input information typically includes vehicle operating condition, it requires torque demand, information on the required torque for various driving condition, data on traffic pattern and congestion, which helps in predictive energy management, analysis of driving habits such as aggressive or conservative driving, which influences the power demand and energy usage. The other important part is the outcome of the control algorithm. So, based on the input data, the control algorithm produces output that guides the vehicle's power management decision. So, the output that the task of the output is to activation and deactivation. It issues a command to turn on or off a specific vehicle component such as electric motor or IC engine or power converters or similar other component based on the driving condition and power requirement. So, the output of the control algorithm should have a information that it should activate this component. Another thing is the modifying the operating region of the component to optimize performance and efficiency. For example, operating the electric motor at its peak efficiency point or switching the internal combustion engine to low load condition when not required for propulsion. So, in that way we are creating a balance in utilization of electric motor or electric propulsion system and mechanical propulsion system for achieving better performance and higher energy efficiency and minimizing the losses and emissions. So, a properly developed power management and control strategy should take care of the parameter such as vehicle power demand, monitoring of the battery state of charge, fuel economy, reduced emission, efficiency optimization and smooth coordination between electrical and mechanical component. Therefore, it becomes prime concern to adopt systematic process for power flow control and optimization while designing the controller and control algorithms. So, based on the mathematical model, the power management strategies primarily fall into two categories. First is the rule based system and second is the optimization based system. Each system has its own methodology, application, providing unique benefit and addressing different aspect of vehicle control system. The detailed classification of the power management system is given here. So, initially it has been classified as a rule based and optimization based, and then within the rule based it has fuzzy rule based classification, and then another one is the deterministic rule based. Within the fuzzy rule based it has conventional, adaptive, predictive, and deterministic it is a state machine and all. Similarly, optimization based has again two set of categorization. The first is the a casual or global optimization and another one is the casual and real time optimization, and they have their own set of further classification that you can see here. So, the rule based system utilize predefined set of rules and criteria for managing the power flow and operational state of various components within the vehicle. These rules are often derived from empirical data, engineering expertise, and specific driving condition. The primary goal of rule-based system is to ensure maximum fuel economy, high efficiency and low emission under certain predefined driving profile. They operate based on the real-time data and immediate condition using a set of if then else rule to make decisions. Some of the characteristics of the rule-based system are given here: heuristic and decision tree. The rule-based system often use a heuristic, decision tree, state diagram and flow chart to manage and optimize the operation of each vehicle component. These rules are typically simple, straightforward, focusing on a specific condition such as vehicle speed, acceleration, battery SOC and load on the vehicles. Another one is the component level optimization. This system tend to optimize the performance of individual component rather than focusing on the vehicle as whole. For example, a rule might prioritize battery usage when the battery state of charge is high and switch to engine power when it is low, without considering future driving condition or overall system efficiency. Another one is the real-time decision making. The rule-based controller are highly responsive, making decision in real time based on immediate sensor data and predefined criteria. This makes them suitable for immediate response scenario such as quick acceleration or emergency braking. Some of the advantages of the rule based system are simple and low computational requirement. A rule based system are relatively simple to design and implement. They require less computational power, making them suitable for real time application without the need for complex processing capability. Another advantage is predictable behavior. Since the rules are predefined, the behavior of the vehicle is predictable under specific condition, making it easier to anticipate and manage. If we talk about the disadvantages of the rule based system, then it is less adaptable. Rule based system may not adapt well to new or unexpected driving condition that were not accounted for during the design phase. They lack the ability to predict future events, limiting their effectiveness in dynamic environment. And it has suboptimal performance. By focusing on component level optimization, this system may not achieve the best possible overall vehicle performance, leading to potential inefficiencies when these components interact with each other. Some of the challenges associated with the power management control strategies are complexities of control algorithm. As control strategy become more sophisticated, the complexities of the algorithm increases. Developing robust algorithm that can handle diverse driving condition and vehicle configuration is a significant challenge. The real-time data processing, the ability to process vast amount of real-time data from sensors and external source is critical for adaptive power management. Advanced data processing capability and fast communication network are necessary to support these requirement. We have discussed, so till now we have discussed about power management and control strategies, their concepts, how they are being implemented, what are the different strategies available, associated advantages, disadvantages. So, the power management and control in electric vehicle and hybrid electric vehicle is a complex but crucial aspect of modern vehicle design. Advances in control strategies, data analytics and system integration are driving improvement in vehicle efficiency, performance and environmental impact. As technologies continue to evolve, power management system will become even more sophisticated, contributing to the widespread adoption of electric and hybrid vehicle and their transition to sustainable transportation. So, in this lecture we have covered two aspects. One is the comparison of the different electric vehicle and another one is the power management and control strategies, and associated attributes. I hope the learners have received good insight on both the topic covered in this lecture. That's all for this lecture. Thank you so much. Have a happy learning.